It's going to be a powerhouse of wisdom, featuring interviews with thought leaders. Firstly, welcome to the Sash's Corner podcast, Ms. Athavale. To begin with, to understand what is mechanical engineering all about. However, just to the audience, I'm just going to go ahead and talk a little bit about who you are in quick 2 lines. So we have Ms. Swati Athavale, who is an engineering consultant from Pune. She's done her bachelor's in mechanical engineering, something that probably all of us are aware that most of the students these days either get into computer engineering or electrics or electronic engineering. Uh, as and along with the flow, they move from the core business of engineering to most of the times to computer engineering. So this is going to be a good opportunity for all of us to understand what's mechanical engineering all about. Why did Mr. Tovle actually went for it? And the best part is that I would really want you guys to go ahead and do a little more research and also go onto a website called researchgate.net where you will find her profile. And she has had 8 publications in her name and papers as well that have been published. I'm not going to read all of them, but something interesting that really caught my eyes were sensitivity analysis for structure, bone noise reduction of diesel engine, influence of cabin modal density on vehicle interior noise, full vehicle frontal crash, and rollover simulation using LS Dyna 3D and experimental validation. There's a lot more that you can read here. Interesting about the car crash simulation studies using explicit nonlinear finite element analysis. So there are a lot of papers here, and very interesting because we haven't really heard a lot of women per se who may be into this area of engineering, and that's why we would want all the students, not only the men, not only the boys, but also the girls, to really, really listen into this podcast and understand what are the pros and cons, what are the interesting elements and aspects of mechanical engineering is all about, and what more can you learn and then implement and then give back to the community and the society and make your career, obviously. So again, we'd like to welcome you, Ms. Athavale. Thank you so much.
Uh, I'm really thankful to you, Mr. Sachin, Dr. Sachin, to have introduced me so exhaustively and inviting me on your podcast. I'm really, really thankful to you.
Let's begin with what is mechanical engineering all about and why did you
Yeah.
pursue it? You've been a very senior person now. It's not that mechanical engineering was a trend way back when you
Yes.
started. So,
Yes.
what is mechanical engineering and how did you get into it and why?
Yes. 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 I am a 1983 graduate from the College of Engineering, Pune. And now, as you very rightly said, that was the time when not many girls used to choose this stream. And in fact, it used to be said that what will girls do there, and they are wasting a seat and all those things. So, it was my liking all the time. Now, just to explain how and why I did get into this stream, is I always liked physics and mathematics. And my father was a MSc in applied physics and applied mathematics. So, I used to discuss with him. So I thought that I would become also MSc like him in one of those streams. But then my father was also a researcher, and he was researching on the fluid dynamics and rivers and the flows and things like that. So that was his area of work. So he one day, explained to me that while doing his research, he always felt the necessity of engineering background. And he always felt that if I want to construct something which I am thinking about, I need some engineering knowledge. So he said, from years to come, engineering is going to take a front seat. So that is how he encouraged me to go for engineering. And then obviously, because mechanical engineering became a very obvious choice for me, since I always like to work on physics and visualize. So I always imagined myself as a mechanical engineer for the years to come. And what happened was, my elder sister is a doctor. And at that time, when I passed 12th, from on the 12th marks, we could get admission.
Yeah.
CET was not there. So in 83, we could get admission based on our 12th PCB and PCM PCM marks. So likewise, I got admission in both streams. Like I had applied for Medical Pune and I applied for COEP and I had got admission in both. And now there was $1 million question to solve because my elder sister is a doctor, and obviously, like that was the time when people used to think, no, girls, doctor girls, that is a better career for girls and all that. But then my inner voice always told me that no, 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 I want to become an engineer. And my parents were very supportive. They said it is your choice. You have to tell us what you want to do, and we will, support you. So that is how I got into this race. See what?
And why mechanical engineering? I'm sure there were other streams of engineering as well.
Yes. As we know that core engineering subjects were being taught in COEP that time. One was instrumentation, second was electronics, third was mechanical, fourth was civil, and fifth was metallurgy. So these 5 departments we had, and I chose mechanical because, as I said, I always had liking towards structural physics. Means whenever in the 12th I used to study, we had bit of everything, no? We had electrical, so I knew that electrical needs your more abstract thinking, and I was more towards visualization, and that's how somehow I don't know how much students understand in the 12th standard. Based on my experience, I feel that it is just my inner voice which told me that I like visualization. And even now, after 40 years of now, this year I'll complete 40 years of my graduation. So wow. I still feel that okay, I'm in the right place, very right place. So that's how it is, like physics and visualization, basically, of structures.
Right. From a student perspective of probably from the students who are in their 8th grade, 9th grade, 10th grade, the main element, the main question arises as to some people have already started focusing on their PCM at the moment. Some people may have started focusing on PCB. But when it comes to, let's say, mechanical engineering per se, PCM is what obviously people, students would want to go ahead and focus on. However, in terms of likeliness and favorite subjects, may not be the case that they may like physics all the time. But math and chemistry is somewhat probably they're more comfortable with. So what is it probably you might want to give an advice? How should they really work on physics? Or especially the ones, the subjects, not the subjects, but the lessons or chapters where they're very complex. How would you help them to make them easy in form of, this is the way you should start learning a particular subject. Physics, when it comes to mind, it's all about formulas and stuff like that, which is hard to mug up at all the times. However, there are students who are not very good at mugging up things, but they're more into understanding the concepts, which probably are reinforced into their minds, and that helps them to go ahead and respond and answer their questions in examination.
Yes. Right. I'll explain a little about this. Now, in today's scenario, people have to give CETs, entrance exams, and that is where the real problem starts. Because why I call it a problem is because children have to, in my opinion, children have to understand the subject first. All students have to first understand the subject. Once they understand, they need very little to mug up. Why? Because physics is such a subject that if you understand, you can derive your own formulae. Like our time, we did not have the CETs and there were no MCQs, so we could describe things. So if you understand, you can describe it better. So one-liner questions were not there that time. Now, why again? Today's children have a lot of one-liner questions for which they feel that only mugging up is going to help them. But my advice to them would be, when you know that at the end of 12th grade, I have to give a CET, start from your 11th first day to learn the subject, to understand the subject, so that it fits in your head so properly. If you need some help from your teachers, nowadays Google is available to everybody to describe things. You don't have to visualize anything. There are videos available. There are lots of material available. Go to a good source and learn it. So if you learn subject like physics properly, it fits into your head so well. that you start thinking in physics language. There is a language to every subject. This might sound a little absurd, but I feel that, every subject has its own language of speaking. So likewise, you start, understanding physics so well that you can yourself start deriving thinking in making up the formulae. But this happens for full 11th grade. Now in the 12th, you have to give an exam which is time bound. For time bound exams, yes, little mugging up is essential. Like we learn tables. Be ke be, be dune char. When we learn, then only the answer comes very quickly. So when you have to give MCQ exam, you know that you have to solve 100 questions in 90 minutes. You know that one question gets so much time, and you really have to back calculate on your thinking process. So that for that purpose, now in the 12th grade, you start really mugging up formulae so that it has to come, like even if you are in a sleep, it has to occur to you that this is the answer. So this way I look at physics. And to add a little to this, my elder son actually he did his JEE, and he was all India rank 83 when he got into it. He got into Powai electronics stream. And of course, I know like what all drill he has gone through in terms of giving exams. Yes, problem solving becomes very, very critical, time bound. For that, little things have to be mugged up. But still, if you have understood the problem, it's very unlikely that you won't remember things. Even if you miss out something, because you have understood, you will know, no, this is not what I am correctly remembering. It should be that way. And my younger daughter, she has given NEET, and she went into MBBS. And she was also 39th rank in the state, and she got into GS Medical College, KEM. So both of them have given, entrance exams into different streams, and right. I have witnessed them doing it. And what I could help is for just help them how to be time bound. How do you need to back calculate, and how do you need to fit your like you have read so many pages in 11th, but now in the 12th you have to revise everything. So how time bound you should be, how many months are you having? Really, you have to go to those details. That I am having 9,000 pages to read and I am having 3 months each day. How much I have to go through? But this is possible if your subjects are very tightly in your mind in that first year 11. So this is how I will describe this as.
Right. I think you really made two important points here. Number one is that every subject has its own language. Physics will have its own language, chemistry will have its own language, yes, and so on and so forth. And two is gonna come back to the point where you made that you made a statement that right from 11th you need to be very serious about what Absolutely. You want to pursue after 12.
Yes.
Because what happens right now is students, even during my generation as well, 9 and 10 were the most important years of our school. So we paid attention during that time, but not as much as very serious students were doing. And then 11th was more of a
relaxed
a big
year.
Break. Yeah, a relaxed
People used to feel relaxed year.
Yes.
Yes, right.
So I think that's an important year where you start your foundation of your...
Exactly.
Right. I think that's an important statement you made. And I think students should really think about this and take it extremely seriously that you're not done after you're done with 10. A 1 year break is not something that you're looking forward with. But 8, 9, 10, I wouldn't really say 8, but 9, 10, 11, 12. Again, 4 important years.
Yes.
You need to be extremely serious about your studies.
Absolutely. And I would add a little more to this also. See, 10th is a very overrated exam according to me. You don't need to mug up for 10th. You understand the subjects in 10th. Even if you get a little less mark, it doesn't matter. Parents also have to understand this. We are in 10th is the family statement. We are in 10th this year. We are not in 10th. We have to understand subjects. Even if you see what happens, giving exam and understanding subjects are two different things for some weird reason. Sometimes even if you have understood, if you don't put it in the language what the question needs, you don't get good marks. Or MCQs, if you're not able to, MCQs and knowledge also sometimes then go along. It's just because you don't remember certain things, you remember them wrongly. What you say, doing very extempore mistakes like that, matters a lot. But I would suggest that in 9th, 10th, Don't give too much of, and parents have to really understand this. Don't give too much of tension for obtaining marks. I got 91, he got 95. You should get marks. I'm not saying for getting into a good college, but ask yourself that whether your child has learned it properly. Because if that 10th foundation of subjects is good, no, 11th becomes easy. And then children are not so taxed that they want to call as a relax year. Why they want to relax? Because they have worked very hard in 10th. उतना जरूरी नहीं है मेरे ख्याल से.
Right. But don't you think today's education system, where students are also brighter these days, for sure,
Yes.
and a lot of results that I've been hearing is that easy 90%, easy 92%, easy
Yes.
94%.
Yes.
So, not really understanding, has the authenticity of that education has fallen a bit? Has it gotten a bit downgraded, or is it really? We don't really understand whether, how is it possible that left, right, and center students are actually scoring 93% and 92%? So,
Yes.
what are your thoughts around this?
My thoughts are exam pattern had changed. My means I am not an educationist, so I have nothing to comment on that. But from my time when I studied engineering, and like when my son studied, when I have an elder son who passed his 10th grade in 2003. Okay, and my daughter passed in 2010. So within those 7 years, also exam patterns have changed. They have become more MCQ oriented. Why are they doing it? Is because they know that MCQs are the things children have to solve later. So what happens is number of descriptive questions, according to me, have reduced. That gives you them very good marks because they have mucked up very well. But nobody has bothered whether they have learned the subject. These two, unfortunately, are different things. So I think that is the reason for all this. You will see a 10th grade person who has obtained 95% mark really struggles sometimes when he goes to 11th, 12th for CETs. Or even these people, when they go to engineering college, many a times they feel that, okay, I am not able to understand things because of these things. Learning has taken its backseat.
Right. So MCQ pattern has both pros and cons. More cons, I would say, rather than pros. Pros in a form where I think probably the teachers want to test the children how quick, how time bound, and how accurate they are in in quick time in order to respond or answer to those questions. But that doesn't gauge the depth of the understanding that the student or the child has really gone through. And as you
Yes.
rightly said, yeah.
Yeah. But for subjects like physics, now again I'll come back to physics.
Yeah.
Physics is not easy to just muck up and solve. That is the reason students of 12th grade find it difficult to, give physics exams MCQs. Because if they've not understood, and if there is a tricky question, if they cannot derive their own formulation for a particular problem, then there is a problem. Then they really find it difficult. So again, I'm saying, MCQs are designed for a certain result because assessment becomes very objective.
Right.
So there are reasons for that. I'm not denying. And exams like JEE and all that, they have, such complicated, children just won't have one formula to solve it. They have to apply their mind in order to get into the answers. So it's both ways. So that is the reason why learning the subject from starting from 9th, 10th, 11th, he is learning of the subject. 12th is exam giving. That should be the distinguishing timeline, I will say. People have to think like that.
What is the direct correlation between physics and mechanical engineering? And if you can help us with some case studies, that will be really helpful.
Oh, yeah, sure. See, in mechanical engineering, we start with applied mechanics. Then we have 4 mathematics subjects. In that, basically, calculus is covered a lot. Geometry is there. And obviously, there is engineering drawing. So mechanical engineers' base is applied mechanics and engineering drawing. These are the 2 bases we learn in the first year. Mathematics 4 subjects, first and second year. Then comes theory of machines. Theory of machines is an extension of applied mechanics, where we learn, like in applied mechanics and applied physics, these are the basis of all structural, fluid dynamics, fluid mechanics problems. Theory of machines is a link between the mechanics and the design of a particular structure. So in the theory of machines, you learn lot of formulations. For example, suppose I have to. Let us take a simple example. I have to design a table for a particular load. I know that this table has a wooden plank. This table has 4 legs. And now I have to know that if I'm going to keep a load of 100 kg on the table, what should be the section of the legs of the table? Now, this kind of calculations are taught in theory of machines. Like what should be the when if suppose I know that I'm using steel, I know that the modulus of elasticity is E. I know the Poisson's ratio is so and so. Then I know that okay, if I take a I section, what will be the section modulus? What will be the area? What will be the direct load? Whether there will be any bending load onto that. So all these things we learn in theory of machines. And then lastly, it is mechanical engineering design. So there comes lot of aspects of design, starting from aesthetics to the design calculations to proving of the design for a particular application. Now, what are those applications? Usually, there are different kinds of applications. There are static applications. There are dynamic applications. Now, in the dynamic applications, there will be a steady state dynamics. Means you are applying a load continuously with a particular pattern. There are some loads which are transient in nature. Like when we are driving car on the road, there are events coming. Events means there are potholes. In the pothole, when the wheel has to go, this is a transient loading that your car gets. There are different design parameters to see that. If there are accidents, there is crashworthiness. So if you have to study on engines, engine is running at different RPMs. So at a particular RPM, if the engine is running for say 1 hour or so, it gets into a steady state. So these are steady state dynamics. So depending upon when all this happens, there are structural failures. The failures can be due to impact, due to crash, due to fatigue. So now these fatigue failures also, I have worked a lot on fatigue, and I go to industries to advise the design teams in order to calculate the fatigue damages and what would be the fatigue life of a particular component. So fatigue happens due to cyclic loadings. So these are all the parameters, and all these things are not taught at the undergraduate level. Undergraduate level, actually up to mechanical engineering design and basic design parameters like static, dynamic, and lot of structures like gear connectors, chain mechanisms, bolted connections, simple structures, civil structures, mechanical structures, a lot of things. Those are all covered. But these fatigue or crash, these are all added subjects, and people when they do post graduation, they think about it most of the time.